Hello again, my fellow 105 class. It's me, Noah Housley, again with this time it's the review of the lecture today and the reading that we had. So let's go over it. First thing she said in class that gave me a feeling of relief, she said, don't worry about standard deviation. When I was reading in the book, it was pretty confusing. I'm not a stats person myself, but if that comes up on a test, that'd be horrible. But as far as she said, if the deviation from your different tests, between tests, is less than 1%, it counts as precise. Anything over that, not precise. Furthermore, deviation that's less than 1% of your truth, so if you're less than 1% away from the actual answer, then that is accurate. So that's precision and accuracy, and making sure that we are less than 1%. And just a reminder, precise, and the difference between precise and accuracy. Precision is you have the same place multiple times, and then accurate of truth is that it's in the right spot. Okay, very good. All right, so we spent a lot of time in class about sig figs, as well as the history of, I guess, why we need measurements. We'll go over measurements in just a second. But sig figs, first thing to know is that sig figs are, the reason they are here is because it lets us know how accurate they are. For example, if I have a scale that only gives me 2 decimal places versus a scale that gives me 3 decimal places, I know how accurate that can be. This one can never be as accurate as this one. And so that's why we have these significant figures, is it gives us the measurement that we can use, that we know about. That's really what it's about. Is sig figs give us something that we know. We can't add something that we don't know about. That's why we need sig figs, is because we can't be more precise. We can't be more accurate, more like, than our measurement gives us. You know, we can't give a better measurement than that. So let's go over the rules. So non-zero numbers are all sig figs. So 1, 2, 3, so on. Captive zeros, so like 101.01, speaking binary here. These are all sig figs. Even these zeros, because they're captive in between non-zero numbers. Trailing zeros after a decimal. So this could be confusing. So if I have 3.0000, all of these are sig figs. For a similar reason, that's why these are all sig figs. If I have 0.124, then these are all sig figs. That holds a place. Well, not sure why that's a sig fig actually. Anyhow, things that aren't sig figs is if it's just a placeholder, so 0.0001. None of these are sig figs. No sig fig. Or trailing zeros without a decimal, so 1, 2, 3 million. Without a decimal, none of these are sig figs. Suddenly, if I put a decimal there, all of these are sig figs. Okay, so keep track of those. Hopefully those are easy to remember. All right, and then we have this giant list. She asked us to memorize this today, and we just read about it. So I wish I could come up with a cute song or something that would help me remember. But try and just remember. I got from Giga, and so I don't know if that helps. It's not alphabetical order either. So, well, actually, yeah, not really alphabetical order. Rough. Okay, so first we know meter. Meter's 1. And so we go up from giga, which is 10 to the 9th, denoted by a G, and 1 gigameter is an example. Big M is mega, which is 10 to the 6th. Little k is kilo, for like kilometer. Little h is hecto, for 100, like 1 hectometer is 100 meters. dA is deca, which is 10, Not to be confused with deci, which also kind of means 10, but it's the smaller 10. It's dividing by 10, and that one's fun because it's denoted, if it was in meters, it would be dam. Deci is 0.11 decimeter. Centimeter, we know. Millimeter, we know. Micrometer is 10 to the negative 6, so that's negative 10 to the negative 6. Not negative, it's 0.0000, so on. Nano, 10 to the negative 9th. Pico, 10 to the negative 12th. And femto, 10 to the negative 15th. So, yeah, really try. Just the hard ones are probably micro, nano, pico, and femto. Just micro is 10 to the negative 6, nano 10 to the negative 9th, pico 10 to the negative 12th, femto 10 to the negative 15th, and then giga is 10 to the 9th, mega 10 to the 6th. Try and, usually they have similar, just remember micro is small, mega is big, and they're both 10 to the 6th, or negative 6 respectively. And remember that giga and nano are both to the 9th power, either divide or multiply. So, yeah, maybe it's just straight out memorization for that list. Rough. Okay, dimensional analysis. So this one's fun. I like doing this because I do it a lot. So I just did a problem a few minutes ago where I had a car that was traveling at 45 miles per hour, but I wanted an answer in feet per second. So what I had to do was I had to do some dimensional analysis and convert. That's why dimensional analysis exists. So it's easy to think about if you think about the units for measurement as things that you can play around with in algebra. So imagine that there's this box around miles and this box around hour. Okay, and I'll put mile, there's seconds here. Seconds and feet. Okay, so units can be kind of put together, and that is a unit. Think about that. That's one unit. So what I have here is 45 miles per hour. And make sure you don't write mph, that's confusing. Just put divided by an hour. So mile divided by an hour. So then I have 1 hour is equal to 3,600 seconds. That's how many seconds are in an hour. And I have 50 to 80 feet in 1 mile. How I decided which one was on top and which one was on bottom was I look at what I want to get rid of. I say, what do I want? I want feet per second. And then I think, okay, so I have miles over an hour right now. So I want to get rid of hours. So I'm going to put that on top, hours. And I want seconds, so I'm going to put, seconds on bottom. Okay. And I want seconds on bottom, so that's good to note too. Like, okay, I want seconds on bottom, so I'm going to put seconds on the bottom and get rid of the hour. And then I also wanted miles to go away, so I put miles on the bottom so it would cancel out, and then feet are on top like I want. So now what happens now is I treat these as like variables, so I say, mile, so those cross out, so that box is gone. Then I have hour and hour, those cross out. Now do you see why I put it on the opposite side from where I want it? And so then what I have is I have 45 divided by 3,600 times 5280 gives me the right correct feet per second. And if you multiply this out, so it's going to be, remember there's this line right here, and so you multiply 45 by 5280 and then divide it by 3,600, what you get is 66. So that answered that question, that your car, if you're traveling at 45 miles per hour, you're going 66 feet per second. So that's fun to do. All right, that's today's class.